Smith is building a 4-strand barbed wire fence around a square pen that's 240 feet long on a side. So let's not go any further. Let's just really talk about this part right here. A square pen that is 240 feet long. Now, if you want more room, there's not a ton of room you can see within these problems. Feel free to write this on a sheet of paper, and you can staple it to it if we need to so you don't lose it. But feel free to write this out. But if not, if you can fit it in the little space that we're given. I wouldn't go further with this problem until I actually drew a square, and you will find that Mrs. Hott is not the greatest artist, but I can give that information, just a visual, so that we can plop the information they told us. So they said that Mr. Smith did a 4-strand barbed wire fence around a square pen that's 240 feet long. So draw that picture. So put 240 feet. So you can put FT. So that's the abbreviation for feet. Another thing you can do is you can put one little quote, one tick, one, I don't know what that is, but that also designates feet. 2 of them designates inches. 1 of them designates feet. I don't care if you want to use feet, FT, or if you want to use that little quote thing, feel free to. But that is going to designate feet. Okay. Now it says, barbed wire is sold in 100 yards. How many rolls of wire will he need to buy? Okay. So the wire, does it fill up the space, or does it go around the thing? It goes around the thing. Around the thing should pop into your brain, perimeter. Now flip to the front of your page, and can somebody share with me, how do we find the perimeter of a square? So you'll have those formulas. Okay, so the perimeter is 4 times whatever one side is, so 4s is common. We're doing the perimeter area paper. 4 times the side, and Easton told us that it was then 4 times 240. And it's going to be feet because it is just a length. Think of physically stringing that barbed wire, okay? Now that would be 1 loop around. How many strands look at this little line here. It says 4 strand means he needs enough wire to go around the pen 4 times. Because he might need like the top layer, and then, a few inches later, another one, and he does that 4 times. Yes?
Does that mean that once you get your answer for 4 times 240, you divide it by 3?
So because I like your thinking, let's draw a picture, and again, don't expect my pictures or anything magical here. Okay, so let's think these are this is the fences, just don't expect again there anything magical here, but it's square, right? Okay. Again, don't. But if we think about the fact he puts 4 layers of barbed wire, so he needs a layer there, and assume this is going all the way around. Sorry, but so if you think about it, says a 4-strand barbed wire fence around the pen. This 4 times 240 is only once.
So you multiply that by 4.
Yes,
and then
okay,
divide by 3.
exactly.
Gotcha.
So do you see how, even though you can tell I can't draw like amazing pictures, but just that visual of what's happening is a very important tool in mathematics, in anything, to have a little kind of blueprint of what you're doing. So what Easton told us was one of the levels around, and so if you do 4 times 240, that is 1 perimeter, 960 feet. But like Tommy said, we need 4 of those, right? And so that would be 960 times 4. What is it, 2,840? Oh, 3,000. Now, here's another trick I'm going to tell you about math word problems.
It's 3,840.
Oh, you said it, but I sure didn't write it. I was thinking about the next thing. If you haven't figured out yet, I'm easily distracted. Okay, anyway, so the question we have to ask ourselves is this one right here. Did we answer that question if we said 3,840 feet? No. So you always have to, and whether I'm teaching about the ACT or the SAT or calculus or algebra or math, applied math, same thing. Did you really answer the question that you were given? Well, the question we were given is how many rolls of wire will we need? How much is in one roll? Yes.
100 feet.
100 yards. Do those match?
No.
So that's another problem. So that's great, you picked up on that. Okay, so let's go back to the 100 yards. Okay, I know we're squishing things in here, but 100 yards is how many feet? So every yard, this is, well, I think it's a meter stick, but we'll ignore that part. Okay, so ignore this little piece. Okay.
300.
This is a yardstick. Well, technically it's a meter stick. This is a yardstick, up to 36, okay? How many feet is in a yard? 3. Now, most rulers, I think we have one in here that's 16, that's weird, but most of your standard classroom rulers, since you were a little kid, most of them are a foot, most of them are 12 inches. That's pretty common, okay? So if you think of a ruler, there are 3 of those that make a yard. So if we know that every single yard has 3 feet in it, do we multiply by 3 or do we divide by 3? Now let's think. This is a yard. Every single yard has 3 feet in it. So if we have 100 yards, how many feet is that? Is it more than 100 or less than 100? More. So that tells me we need to multiply. Now, another thing you can do is set up a proportion. Again, I'm running out of room here, so let's write it on the board. If 1 yard is 3 feet, 100 yards is how many feet?
200.
To solve a proportion, all you gotta do is multiply the 2 numbers that are across from each other. Whatever number you haven't used, you always end up dividing by. So 3 times 100 is 300, divided by 1 is still 300. It's nice when it's a 1, okay? So we know, we can fill in this little blank right here, that that's 300 feet in a row. Okay, now we need 3,840 feet to get around the pen 4 times. Now, if we think about that for just a minute, let's think about the fact this is not a perfect multiple of 100. So we're going to have to buy a little extra, okay? And that happens when you're painting a wall, when you're getting carpet on the floor. You usually get a little extra. Usually it's not perfect. And sometimes you want a little extra, in case there's a mistake or something like it. But we need to figure out how many rolls are in there. So we have to figure out how many 300s are in there. What math is going to give us that? Yes?
Division. 3,840 divided by 300.
Division. Okay. Now here's where the calculator is going to help us, but we also have to use some logic. Okay, so if we do on the calculator, 3,840 divided by 300, I'm going to show you what the calculator tells me, and you put it in your calculators too. It tells me 12.8. Now, if I go into Tractor Supply and I said, I want 12.8 rolls of barbed wire, they're going to be like, we don't do that. We would have to round up and buy that extra because that's just the way it goes. So we would have to, no matter what, if this decimal was 12.2, 12.3, 12.4, anything, we always have to buy the extra roll to make it all the way around. So the answer is, the final answer for this problem is we need 13 rolls. So we have to buy 13 rolls to get us all around. Now that's technically 3,900 feet, but that's okay. We'll have that extra. But it's, so then we go back and read this question. How many rolls of wire will we need to buy? Did we answer that? Yes. So always with word problems, break it down kind of sentence by sentence. Read that last question one more time and say, did I really answer that question? Because sometimes you do and sometimes you need more information. You know what I mean? Does that make sense? Okay. Let's go to the next one. Everybody have that 7 down? Do we have any questions about how we did that? There were lots of steps to that, wasn't there? Okay, let's look at number 8. Now, before we go further, they have provided a lovely picture, which is great. Okay, so they've provided a picture for me. If you compare that to the front page that we did in class, I don't know when it was, last week. What's that shape?
Trapezoid.
That's a trapezoid. Now, the definition of trapezoid I told you about before is it has one set of parallel lines and one set that is not. So that's a common definition of a trapezoid. So that's a trapezoid. So keep in mind, we're probably going to have to use that, the strangest of our formulas so far. But let's just read it first, because maybe they're not looking for area, maybe they're looking for perimeter, maybe they're looking for, let's see, okay? So Sally builds small planting frames for her greenhouse by assembling trapezoids as shown in the picture. If each frame needs 4 of the trapezoids, how many total feet of lumber will she need for each frame? You will need to think of inches as a fraction of a foot. So that brings another issue to the problem. Okay, so how many, it says, this question here we can kind of highlight. How many total feet of lumber will she need? Feet, okay. So can anybody tell me how many inches make a foot? 12 inches make a foot. So we're going to write down some fractions. My heart broke already. That's crazy. Must have been too violent today when I unlocked my door. Okay. Anyway, glad I saw it now. Okay, so let's take a look, and we're going to make a little chart. So go back to the front page where we have a little bit more room. See right here? Let's just put these fractions down at the bottom right here. Okay, so go to the front page where we have a little bit of room down at the bottom, I think. And let's take a look at how we would do this. Okay, so you guys told me that 12 inches equals 1 foot. So write that little factoid down for us. And then we're going to set up some fractions, okay? So a very common one is 6 inches. 6 inches is 6 out of the 12 I need to make a foot. So that is a half of a foot if you reduce that fraction down. Oh, you can do 6 divided by 12 gives 0.5, however you do it. But 6 inches, half of a foot. Another one common, that's common, you'll see 9 inches. So that's 9 out of the 12 I need to make. So if you looked at my 12-inch ruler, 6 goes halfway. We're talking about 9 out of the 12. So we're more than half. What part of half? What's a number that goes into 9 that also goes into 12? 3, right? So we can reduce that down. And so if I divide the top by 3, I get 3. If I divide the bottom by 3, I get 4. So that's 3/4 of the way. Okay. Let me see if they use any other ones. 6 and 9. Well, let's just add one more while we're at it. Let's do 3. I've seen 3 or 4. Let's do 3. Okay, for now. We'll just keep it fourths. 3 inches is 3 out of 12, or 1/4 of a foot. And this is a foot. I'm so sorry. That's a foot. 3/4 of a foot. This is 1/4. So every 3 inches is 1/4 of the way. So 1/4 and 1/4 is 2/4, and another one is 3/4. So every 3 inches, so 3 inches is 1/4 of an inch, or 1/4 of a foot. And so that's a very common measurement when you talk about like lumber and things like that. Okay, so now you have that as reference. Let's go back to our problem. We're looking at problem number 8. So we need lumber. So think we need a piece of lumber for the 1 9s. We need a piece of lumber for there. We need a piece of lumber to make one frame. How many frames did it say that we need for the greenhouse? How many of them do we put together? 4. We put 4 of them, okay? So Are we doing the area of this object, or are we doing the outer perimeter of the object? Do we care about what's on the inside, or do we care about walking around or measuring the outside? So where the outside, if we're just talking about the timber, like the lumber that we're using, or the wood that we're using, if it was inside, maybe if we wanted to make walls on the greenhouse, that's where it would be area. This is perimeter, okay? So let's find the perimeter of one of them. And it really, perimeter is just adding up the outside measurements. So if it's not a great shape, like this one's a little funky, you just add up this piece, just add them up, okay? But we have to do a little conversion. 9 inches was what fraction of a 3/4? Does anybody know what 3/4 is as a decimal? 0.75. 3/4 is 0.75. Let's add that to our paper. So this is 0.75. This is 0.5. This is 0.25. So 3/4 or 3/4 in your pocket, it's worth 75 cents, 0.75. Okay. So we're going to use the decimals because I think that's probably the easiest way to approach it. We could definitely use the fractions. It's not a big deal. But let's go now to problem 8. Okay. So the perimeter, we're just going to add up the outsides. So the perimeter is going to be 2.5, because we have to convert that, 2.5, plus 1.75. Remember that 9 inches was that 3/4, 0.75. Plus 4, we don't have to do anything with that. And then 1'9", remember, is 1.75 again. And that is how many feet we need for one of the trapezoids. So 2.5 plus 1.75 plus 4 plus 1.75. And it is 10 feet all the way around. How many of those do we need to create? We need 4 walls of this greenhouse. So the 4 times the perimeter is 4 times 10. We need 40 feet. So then go back to the question again, and did you really answer the question? How many total feet of lumber will she need for each frame? Now the frame are the 4 trapezoids. We did the 4 times, so we're good to go. We got what we need. That's the answer. Let's kind of circle it so we know that's the answer we were searching for. Good so far for that one? Okay, let's move on, and let's do 9 together. It says the house plan shown to the right. I don't know, is that to the right? I don't know. But anyway, underneath there is it drawn to scale that a centimeter is equal to 8 feet. How many total feet of gutter will be needed to go around the roof? Now, I had you get a ruler. So I need you now to measure the length of the house in centimeters to the nearest tenth. I want you to measure on your ruler to the nearest tenth for the length and for the width, and then mark it on the drawing, and then we'll tell you what to do from there, okay? So everybody take your ruler. Remember, the nearest tenth should be, the centimeters are naturally usually marked that way. If your ruler doesn't have centimeters, grab yourself a ruler and measure for me the length and the width of this house in centimeters to the nearest tenth. And I will grab myself a ruler and do it to my paper. Can't do it on an iPad, but I can do it on paper. Try to be accurate to the nearest tenth. And then we'll share in a minute. Okay. So Chase, share with us. What did you get for the length of the house? Did you do the length of the house on your ruler? What'd you get? Did you do it this way? Is that what you did? That's where you got the 3? Anybody else get anything different? I got a little under 3. I got 2.7. So Chase, we're going to go a little bit more accurate than the 3. 3 is okay, but that's. I think if you go to the nearest 10, and make sure you're using the centimeter side. Okay. Jordan, what'd you get for the length of the house?
5.
I got 5, pretty close too. I kind of debated, but I thought it was 5 too. Now, if you got 2.6 or 2.8, I think you're okay. 3 might be a little off. Be careful where you're putting the 0 on there. That could make the difference. Okay, so we've got these measurements. Now, this is a scale drawing, and we're going to talk about scale drawings a little bit more next week, I believe. But let's think about what they told us. Every centimeter is equal to 8 feet. Okay, so we have these centimeter measurements, and so we need the feet of the gutter around the house. So we need to convert those to feet. So here we're going to set up some proportions, and we're going to practice proportions today, but we're going to explore them more later. But let's do this one first. I know that 1 centimeter is equivalent to 8 feet. That is our first measurement kind of scale. 1 centimeter is equivalent on this particular scale drawing to 8 feet. Now, since I put centimeters on the top, this 5 centimeters has to go in that same location. And our unknown, our X we'll call it, is the feet. We don't know the feet. Now remember, I told you a little bit ago, to solve a proportion, the quickest way to do it is to cross multiply. Whatever numbers are across from each other, multiply those and divide by the one you didn't use. So 8 times 5 is 40. Divided by 1 is still 40. So it's great when that's a 1, because then you don't have to worry about it. So we know that this is 40 feet. So the 5 centimeters is 40 feet. Now it makes sense. If 1 is 8, 8 times 5 is 40. Makes sense, it's 40. So let's put 40 feet down here. Okay, so we got 40 feet. Now, let's do the 2.7. Set up the same proportion again. 1 centimeter is 8 feet. So 2.7 centimeters is how many feet? You'll see, same cross multiplication. Multiply 8 and 2.7, divide by 1. 8 times 2.7 is 21.6 feet. So let's put that on there. On the house, do the gutters go around the house, or do the gutters somehow like cover up the roof? What do the gutters do?
Around the house.
They go around the house, right? And so we're talking perimeter again. So you always want to think about, does it cover it up somehow? Does it cover up a wall or a floor or a roof? That's area. But if it's on the outside of it, that's perimeter. How do we find the perimeter of a rectangle? You could just add them up. You could just add them up. How many lengths do we have to get around the house? How many of the lengths do we have? 2, right? We have 40 here and a 40 here we got to get around. How many widths do we have? 2. So that's where that formula comes from. One formula you can use is that perimeter is 2 widths plus 2 lengths. That's a total option. But just walking it around and going, I'm going 40 and 21.6 and 40 and 21.6 works totally okay. Perimeter's a nice one because you have some options, okay? So, but if we do the formula, it's a little bit of a shortcut. We have to do 2 times 21.6. That is so not 21.6. Which is 43.2. We have to do 2 times 40. That one's easy to do. That's 80. And then we just add them up. So it's 123.2. What are our units? We switched the centimeters to feet. So make sure you put the feet. Let's circle our final answer. Now, always go back. Did we really answer the question that they gave us? How many feet of gutter are needed around the roof of the house? Yeah, that's the feet of gutter, okay? So you always check, did you actually answer the question you're given? Make sense? Okay. So those are kind of those word problems. We're going to explore more as we go because, again, that's one of my goals for you is to be better at word problems when you end this school year than you were when you came in, okay? Now, could you please, let's go down to the next page, or for me it was down, go to the next page. And we're going to focus first on number 2. We're going to do 2 first, then we'll go back and do 1, okay? Let's talk about 2 because you need to use your ruler. On number 2, it says on this paper, accurately draw 1 square inch and 1 square centimeter. Now, I've been drawing a square inch up on the board. It's not completely accurate, but, you know. A square centimeter is going to be a lot smaller. So what I want you to do now is with your actual ruler, try to make a square that's an inch by an inch. Try to make a square that is a centimeter by a centimeter, okay? So try to get as accurate as you can. And I'll do the same on my paper so then I can give you, for reference, we can see how big they should be. Now, of course, when it's projected up on the board, it's not going to be a square inch or a square centimeter, but I did try to kind of line it up with some references when I did it on paper. So yours on your paper in relationship to the words should look something like that. And here's mine again. Don't expect it this great, but there's mine on the paper. Okay. So a square inch is kind of what I've been drawing. Those two aren't horrible. So this is what yours should look like when you drew it yourself. It should look something like the two I've got here. So if yours looks something like that, you've done what you need to. Okay. Now, now that we've drawn that, so we have that as reference, let's go ahead and start up with number 1. It says, to describe what a square foot is by filling in these blank. A square foot is a square that is a foot on each side. Now, you don't really have enough room to draw that on your paper. I'm trying to see where I put my ruler. There it is. But if you were to draw a square foot, again, don't expect this to be beautiful, but it'll be as good as it's gonna get. So look at the difference. Now, I also want to talk about, you can tell the ones I made by myself. Okay, that's a square foot. How many of these little square inches do you think are gonna fill that? Anybody have an idea? How many square inches would fill this? Now, again, that's only two. How many of those would fill it? Yes,
48?
more than that. I know what you did. You're on the right track as to, you thought about how 12 relates to it, that's good. How many inches is it up? A foot is how many inches? 12. How many inches is it to the left?
So, well,
It's 12 by 12, which is 144 square inches. You need 144 of those little squares to fit in a square foot. What about a square yard? Think about even more, if I could draw, that's probably close to, not far away from the square, if you made this into a square. That's a lot, okay? Okay, so let's keep going. If a square is 1 yard on each side, we call that 1 square yard. Okay? So it depends upon the measurement you're using. Here's a square centimeter, here's a square inch, here's a square foot. A square yard would be 3 feet by 3 feet, 36 inches by 36 inches, 36 times 36, big number. Okay? Let's keep going. 2 ways to abbreviate a square foot would be to put a foot with a little square mark. So mathematically, that's okay. Another way I've seen people abbreviate it is they put SQ, FT. That's okay. So feel free to use either abbreviation. For me, I don't care. You can put SQ in front of the foot, or you can put feet squared. Go for it, whatever you want, okay? So with that in mind, how could you abbreviate a square yard? 2 ways. Give me 2 ways. Somebody tell me 1 way. Yes?
SQYD.
Yep. So you can do SQYD. What's another alternative way to abbreviate a square yard? What's another way?
YD squared.
Yeah, put that YD. Make sure you have the YD squared. Yep. And then it says for C, it says abbreviate 1 square centimeter using the exponent 2 for squared. And that just means you want SCM. Take the abbreviation and put a little power of 2 on it. Okay, let's look at number 4. And then I think we're going to stop there. Perfect, we'll finish that page, okay? Let's take a look at number 4. It says, usually we do not multiply like units. For instance, the problem 3 hours times 2 hours does not equal 6 hours. The units don't make sense. But it does make sense to multiply units of length times their self. Feet times feet is square feet, or feet with a squared, or FT with a squared, okay? So in this problem, if we are thinking of the area of a, shed, the floor of a shed is 5 by 2, that's okay to multiply them, but it would be 10 square feet. And if you put SQ feet, you're okay. If you put the square on the foot, that's okay too. 8 by 3 meters. Okay, now this is meters. This is a meter stick. So it would be 8 of these long and 3 of these high or whatever. And so 8 times 3 is 24. That's your number. Your units, you can put the SQ with an M. The abbreviation for meters is M. Or you can just put an M with a little square on it. Okay? Either way is fine. Okay, everybody good so far? Does it make sense what we're doing? Any questions? I think your names are on these. I believe they are, but just check to make sure. Please pass them forward so I can give you some points, and I will give them back to you tomorrow. So in case anybody doesn't bring them to class, Dan. Right? Did you hear me, Dan? I said, in case somebody doesn't remember. So make sure you put your name on, pass them forward. Now, if you find your other ones, let's staple them together so then we have them. Oh, yeah, and you did anything on paper? There's a stapler right here. Good idea, thank you. Feel free to let's staple those together so that we have all that. Yeah, definitely. Thank you. I appreciate that. Let me scroll. Easton, that good? Thank you, thank you. That's okay. That's because an abbreviation for meter is M. You can just put M with a little 2 on it. Oh, I didn't scroll up. There we go. Okay. I always think we're up or down. It's, I don't know. Okay, anybody else need to turn theirs in? Okay, thank you so much. You guys are awesome. Hopefully you're learning something along this journey here.
You have one and two.
There you go. Have a great day, you guys. Have a good one.
Here you go, Tom.
Why, thank you.
Thank
I
you.
hope you feel better later. Can you go to the nurse and get a, like a Tylenol or something?
I leave at 11:16.
Um,
I'm just gonna wait until I get home. I'm probably just gonna take a nap.
Gotcha. Sometimes that's what if you have a headache, that's what you might need.
Yeah.
Take care.